Okay, it looks like we are just about on time to get started. So welcome to everyone who is joining us for today's reactive session, which is Rust Understanding Common Concepts. So you're very welcome to today's session, which will take place over the next 60 minutes. There will be the opportunity to ask questions and to ask any questions you have throughout, which will be answered by the end of the session. So if you've any questions, feel free to pop them into the Q&A window and we will monitor them throughout. This session is being recorded and will be made available to watch on demand on the Microsoft Reactor YouTube channel. That will usually be posted within a couple of days. The link will be posted out to you on the meetup group where you signed up. Just to go through a bit of code of conduct before we get started today. So this is just a reminder to everyone to be aware of others, welcoming and respectful to everyone throughout. We may see people from different backgrounds, different identities, so just to really be mindful of everyone who's with us today and just to enjoy the session throughout too. Our speaker today is Freek van Keulen from the Netherlands, who is a language teacher for C++, Java, Python and Rust. We're really delighted to be welcoming Freek here today and looking forward to hearing the session with him. So I will hand over to you today to get us started, Freek.
Well, thank you, Emma, and welcome to all who has entered this session. Yeah, we have 60 minutes, so I will jump right into the topic. First, I have to share my screen. And let's start off with the basic concept of Rust. First, we start off with creating use of variables in Rust. And that I'm assuming sort of you all have a little bit of a programming background entering this session. But still, we start off with variables in how to do that in Rust. And the way to do it is to start off with the let keyword and then a variable name and then a value. So this way you define a variable a number with the value 10, and that is the first variable we now made in our program. We can run this, and if we run this, of course, it will work. Oh well, it will not work. This is because Rust is pretty picky. And now Rust is still complaining. What you see here is a kind of standard behavior of the Rust compiler. It's very picky on everything you do. And personally, I find this very nice because when you got through the compiler, your program is already of a better quality. So the thing what's happening here is the variable is not used yet, the a number, and he's suggesting, well, you probably should do something about it. And there are few ways of handling this, and the compiler is also suggesting the ways you can handle this. But the first way, of course, is do something with it. And the first thing you do in a small program is to write it to the console, and we can do this like this.
Freek, sorry to interrupt you now. We're just getting a few comments through to ask if the font can be enlarged, if we can zoom in.
This would work then. I
Great.
did a quick fix, yes. And if I now run, it works. So we now have our first very little program. We have a variable a number, we put in a value 10, and we print the value out. And of course, we can have a different kind of variable, for a boolean, for example, and then it goes like this, true. And of course, to be ahead of the complaining of the compiler, I will put it on screen immediately. And now this is also working. So now we have two variables in place, which I printed out to the screen. There is one more thing to notice about this, that there is no typing at the moment, but there is behind the scenes, because first is because I'm using here a 10, it's inferring that it will be a integer number, and because this is a true, it will inferring that this variable is of type boolean. And I can, of course, do only boolean integer things with the first and boolean things with the second. Now let's try to put something to change the first variable. If I have the first variable and I want to change it, I can do something like this. We'll put number 6 in it, and if I run this, it will give me a warning. And the warning is cannot assign twice to immutable variable a number. And this is the feature of Rust, that every variable in Rust is immutable by nature, by default. So the way to handle this is to make the variable mutable, and after I do this, then I of course should print the variable after using it, because otherwise it will complain on not using it. And it's quite interesting, because now it's complaining that this is never used. It's overwritten with 6. So one way of bypassing this for demo purposes is to use the number itself, add 6 to it, and then see what happens. And now it's working. So what I did was I reassigned a new value to the same variable, and then I had to make the value mutable to do that. One other way of doing this is to reintroduce the same variable. When I do again the same variable name, but I use a number again. Oh well, let's do it a little bit different. I remove the mute keyword on this top, and then I put in the keyword let in front of this, and now it's working again without using the mut keyword. And what's happening here is that a number is reintroduced, meaning it's shadowing the old variable. So this variable is a different one than this variable, because the let keyword is used twice on the same variable name, and we call this shadowing. All right, this was the first topic. The next topic we will go into handle is the topic about the data types in Rust. And I will throw in a screen. We have basic data types in Rust, which are numbers. These are the integer numbers. And we have two types of integer numbers, the signed integers and the unsigned integers. And they're all sized from 8 bits to 128 bits. So I have to choose between integers signed or unsigned, and how many bits the integer is wide. I also have the choice to I size and U size. In that case, the integer will be dependent on the machine architecture. So if you're running on a 32-bit machine, it will be a 32-bit integer, and if you're running on a 64-bit machine, it will be a 64-bit integer. Of course, Rust has also the possibility of floating points, and these are the 32 and the 46 64-bit floating points values. And the 64-bit is the default size. Besides that, we have the possibility to use booleans, and these are well, the main basic types of Rust. There is something more to say about character strings, and the first thing is a character is denoted as a character constant as a single quoted letter, and a string is a double quoted string of letters. And I will go to demo again. So if I demonstrate the string part, here we have a string. We create a string from a constant string, and we put it into the variable hello. And after that, we push the letter W behind the string, and after that we push another part of the string behind the string, and then we print it. So this is a little bit a difficult way of making a hello world program. Let's run it. And here we have the hello world program. So let's dissect it a little bit. This is a little bit more complex than you're used to with other languages. First of all, there are two types of strings. There are strings and string slices, and a string literal is a string slice. So what you have to do is you have to convert the string slice to string before you can use it as a string. And after you have a string, you can push characters to the end to it this way. Of course, you have a lot of string functions, and we're not going over that for now, but the main thing to focus on is you have string slices, and a string literal is a string slice, and you have a string type, and you can have to work with them both. And in this case, there is a conversion taking place from the string slice to the string type, after which we work with the string, make it longer, and print it out to the console. Right, so we have a few basic types seen now. We have the integer basic type, we have the floating point basic type, and the string and the string slice. And now we're going to look into the composite types, the first composite types. And one way of doing this is to make a tuple. And a tuple is a set of values forming a collection. The smallest set, of course, is an empty set, and then you have a single one, and well, you're not using them very much because the single set is, of course, just a variable. But then you have the pair, and in this example, there is a triple, and so this triple is formed of a string, of an integer, and of a character. So this is a tuple of a string, an integer, and a character again, and after that, we access the elements of the tuple by index. So this is the first element of the tuple, this is the second element of the tuple, and this is the third element of the tuple. And if I run this, it will run just fine. But you won't see very much, because now we are using this assert statement, which is checking if everything is all right. So assert equals is what effectively is happening is the first part of the tuple equal to hello? And if that's so, nothing happens. If that's not the case, it will complain and throw me a panic. So I will demonstrate it to show what's working, how this is working. You see now it is panicking, the thread main panicked because this assertion failed. This is not correct. So if I make it correct again, the program is sort of silent, and therefore it is correct. So this is the first thing you can do to create a composite type. The second thing you can do is to make a structure. And the structure is more like what you would do in C. And this looks like this. We have here in the three different kinds of structures. And the first one is the C-like structure. The structure has a name, of course, person. And the structure has three fields in it: a name field of type string, an age field of type U8, and a likes origins field of type bool. And in this case, because we're defining a struct, we have to define the types. At this point, we're defining it and not using it. I'm going to show you how to use it in a moment. But first, I go over to the other two ways of making a struct. The second way is a tuple struct, where you have you have a name of the tuple. In this case, it's point2d, and then you have two unnamed parts of the struct. And these unnamed parts are, in this case, of course, the x and the y coordinate. So these are so obvious that you can leave them out, and you can use this tuple-like way of defining a struct. And the last part is where you define a unit struct. Using the function, using a struct, I will copy it because that is a little bit faster. So here we are using I think this has to get out of the main. So what we do here is we create a person variable, and we create a person struct value behind it, and we do it in steps. So we say this person variable is of type person struct, and it contains the values name, Adam, likes oranges, true, and age 25. So this is the way you define a struct. You instantiate a struct. Of course, you can also instantiate a tuple-wise struct, and that will go like this. Let origin, if we want to make the origin point, is point2d. So this is the origin point defined as a point2d struct, defined as a tuple struct. And of course you can make the unit struct like this. And I'm not going to run this because I'm not using it, and the compiler will complain about anything not me using these variables. But you get the idea that this is the way of defining a C-like struct, and this is the way of tuple struct, and this is the unit struct. All right, so this is the struct. The other thing, what you also can do is make enums, and that goes like this. This is a sort of your standard enum. Well, not your standard enum. So I have an enum web event, and this web event has 5 values: page load, page unload, key press, paste, and click. But such a value can also have sub-values, or so the key press can be accompanied with a char value, and a paste can have a string, must have a string in this case, and the click must have a x and a y coordinate. So the enum in this case is giving me the possibility to assign a value to a variable of these 5 sub types, so to say, and it is one of those 5, of course. And this is I think this is in Rust a very powerful possibility, a powerful feature in Rust, to have this enum type, which you can define in a way you like it. So every part of the enum can be sort of a different structure, and that is a very powerful thing to have. Okay, so with all this being said, I'm now going to do an exercise, and I'm going to copy this first and get it into the editor, and I'll make it a little bit bigger. Let's see if this works. Oh, that's not working. All right, I can't get it bigger. So the to-do here is replace the question marks for an actual car instance. So let's look at the program. I have a car struct with 4 variables in it. I have an enum transmission with 3 possible values. And here I have a function, which is a car factory, and I have to make a car at this place, after which it will be tested in the main function. And the goal of the exercise is to create a car instance at this place. So how do we go about this? Well, first we have to make a car. Then we have to fill in all the 4 fields. So color, transmission, convertible, and mileage. So that will be color, transmission, and conversible. And if I now compile, let's do that. I have a typo. It will complain with missing field mileage in initializer of car. So I have here, I try to create an instance of this car struct, and the mileage field is missing, and the compiler says, well, I'm not going to do this, it has to be complete. All right, so we throw in a mileage, and that will do the trick for that part. And now it's working just fine. a few more things. I can take out this color field here, and this is a little bit like JavaScript, I think, where if your field name and the variable which you're putting into are the same, you're not, you don't have to repeat yourself, and then you can do it this way. So that's nice. And that will lead us to the next topic, and that's the topic on functions. We already used it in this exercise, so it came in a little bit through the back door, but now we're going to handle it a little bit more detailed. So let's give another example on functions. These are two functions. I have a function main, which is calling a function with another function, and they're both printing something to the console. So if I run this, sure enough, this is printed to the console. One thing to notice here is that this function is appearing after the main function where this function is called. So it's not yet defined, but Rust doesn't bother. So the order of function is not important. I can put the another function above the main or behind the main, and it will work in either way. So it's not like what you have in Pascal, where you have to define in a certain order to get it working. Just define the function anywhere, and Rust will find it if it is somewhere in your source file. Well, these are of course very simple functions. Most of the time you need variables to pass around, and so we have here an example of a function is divisible by, and this function will check if the dividend is divisible by the divisor, and will return a bool if it's true or not. And the indentation is a little bit off, so let's do it like this. So if divisor is 0, it will return false, and otherwise it will... yes, that's a nice. It will check if the divisor is 0, so you don't have a divide by 0 error, and otherwise it will give you the is divisible by boolean back. And when we run this, it is complaining because the function is never used. And so that is nice. We have to call it then to test it. So if I put in these three assertions to test the function, so if the first one is divisible 2 by 3 is false, 2 isn't divisible by 3 indeed, so it's false, 5 is divisible by 1, so that's true, and 24 is of course divisible by 6, so that's true as well, and the one in this test set is missing is of course divide by 0. If I divide by 0, that would in all cases be false. So let's run this, and this is going quite nice. All right. So this is on the topic of functions, and it's very elementary, of course, because we don't have so much time, but I leave it here for now, and I will go over to the next topic, and the next topic is on arrays. In Rust you have two types of arrays, that is the array type, and you have of course the vector type, and it's just like in Java, where you have an array, it has to be a fixed size thing, and to get around that, you have the vector, which can be a variable size object. So let's first start off with the array, and I will throw in the example code. So here are two ways of defining an array. The first array defines the weekdays: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and it will do so by giving the literal values, and Rust will find out, this has to be a 7-sized array with type string. And in the second example, you see there is an array created of type U8 with value 0, and it will made of 512 elements. So it's initialized with 512 zeros of type U8. So this is the second way of defining a integer. Of course, you want to use it as well, and I do a little bit of different example. This is a array with letters, and then you see how to use an array, the elements of an array. So the letter 0 is the first element of the array, and the letters 1 is the second element of the array. And in this way, you print out the letter A and the letter B in the first and the second print. So let's run this. And the first element of the array is A and the second element is B. The question now is, what will happen if you use an index which you're not allowed to use? So let's see if we put in a 99 here, which obviously is far too big for the array. And it's already failing at compile time. The error, this operation will panic at runtime. So this is not, the compiler will not let you do this, but you can have the situation where you have a variable and you put a value into the variable, and the compiler doesn't know at compile time what the value of the variable is. In that case, you can get a index out of bounds panic at runtime. So it's checking as much as it can, but it can't check everything. So this is the array. The array is a fixed size of elements which are all of the same type. So what is the next step then? The next step will be a vector, and a vector will be a variable size array of elements of the same type again. And this is an example of that. We start off with a vector, and there is something going on here, and this is this exclamation mark, and that's a macro, and a macro is basically generating code for us to keep it a little bit easy on the programmer. And these are also very powerful, but it's a little bit more of an advanced topic to talk about. But when you see an exclamation mark like this on a place like this, then you know it's a macro. And with the print line, you have there as well this exclamation mark. So the first step, we define a vector, and we initialize it with 1, 2, and 3, and that's the vector then. And then the second one, it's doing 10 zeros into the vector. And it's a sort of the same example of the array. The first, we put in 3 static values, well, static is not the right word, but constant values, and in the second part we put in 1 value and we repeat that value multiple times. So let's check if this indeed is working out very nicely, and it does. The initial vector 1, 2, 3, and the 10 zeros, you see there is this 10 zeros into the print. Another thing what's happening, and it's interesting, is this colon question mark within the curly braces. You will encounter this a lot, so I will explain it a little bit. First, the curly braces are a placeholder, and this is for string interpolation. And normally, or well, not normally, sometimes you don't need this colon and question mark, and sometimes you do. And that has to do with the type. Some types will implement a normal print, and some types will only implement a debug print, and this will refer to the debug print. So a vector has a debug print method implemented, and we are using that to print out the vector. If I leave this out, then it tries to use the standard display of the vector, and it is there, so it will complain, doesn't implement the display. So if you want to print out a vector in raw format, then you have to use the debug colon question mark to get that done. And that's true for vector, but not every type has a debug implemented as well. So some types doesn't have a debug as well, and then this will not work either. So, but this is the first line of defense to get something printed out of the console. You first print it like this. If this is not working, you try to use the debug. And if the debug is not working, you have to implement one of the two to get something to the console using string interpolation. All right, so that is a little bit more background on the print statement. And now we're going to jump over to the Hashmap. And I have to do a little bit more clever copy pasting now. So I will put this into here. And I will put a use in before, and then I will talk you through it. So the first step in the main is a definition of the creation of an hash map, an empty hash map. So this line will create an empty hash map for you. And there is a thing going on that it's not having a type yet. And that's a little bit strange, right? Because normally if you do something like this in generic programming, you define the type at the moment you define your variable. And in this case, it's not done. So the first insert statement is really defining the type of the hash map. So the first insert statement inserts a string and a string. So a string pair in the hash map. A string is a key and the string has a value. So the key value are both strings again, and that makes this hash map a string-string hash map. So the string interpolation goes a long way. It goes beyond the first statement, beyond the assignment statement, and can find out, well, oh right, so you mean it's a string-string hash map, so I make it a string-string hash map. Of course, the second one has to be a string-string as well then. So you're not allowed to put in here an integer and an integer, or a string or an integer. The first one defines the type of the hash map, and so they all have to be of the same type, otherwise it won't compile. And now we are having to use it, of course. And how are we going to use like this? And I have to put in a other curly braces. So we have an hash map. We insert one book review, we insert another book review, and another two, and then we're going to check if the book review contains the key Les Miserables. And does it? Now let's have a look. I don't see it. Let's run it. Closing the limiter. now I need my IDE, of course. This one is too much. We got 4 reviews, but Les Miserables ain't one. So because there's no book review inserted with this key, this will fail, and on the contains key in the Hashmap. And then 2 more things. If you you can get the value belonging to the key by using the index notation. So this is the Hashmap, the name of the Hashmap, and I'm using the index notation with the square brackets and the value within the square brackets. So, and this will give me back the value belonging to the key. And I'm now curious if this will run. It is running. I mean, I was curious if it will compile. So it will print. This statement is printed. It's here below here. And the next statement is printed. It's over here. But this one is giving me trouble because this key isn't in the Hashmap, and it will panic. No entry found for key. So you better be sure that you're using the right key doing this. All right, so we're now going to do another exercise to get our hands a little bit more dirty. And okay. So we have here a Hashmap exercise, and the exercise is to declare your Hashmap here and insert some fruit here, and then return the value to the function. So first, let's make a Hashmap here. So first we say Hashmap new. That will do the trick of creating the Hashmap. And then we insert one piece of fruit, and we have to put more fruit in the basket. And the main function will test it, and if it's not containing at least 3 numbers of fruit, it will fail. So let's run this and let's see if it fails. Oh, I have a typo. Let's do it like this. And then it says panicked basket must have at least 3 types of fruit. And that's correct because this is this assert which is panicking. So I have to put in a little bit more fruit in the basket. Let's do it like this. Well, that's a lot of typing, so let's do it a little bit smarter. Apple and orange. And let's see if that fixes the problem. And that fixes the problem. So the exercise was to create the hash map and then insert a few things into the hash map, and then the main function will check if at least 3 pieces of fruit are put into the basket. One thing is also happening here is that this function is returning a hash map, and that's denoted like this. The function is called fruit basket. It has no parameters, and it has a return value with this small arrow saying after this small arrow is the return value. The return value is a hash map of type string U32. And then the returning part is in this last line. The last line has no semicolon at the end. If I put in a semicolon, it will not work any longer, because now the Rust compiler thinks I'm returning nothing, or the unit type if you like. So the last statement without a colon, without a semicolon is automatically the return value of the function. So this way the hash map is created, 3 pieces of, 11 pieces of fruit are inserted in the basket, and the basket is returned through the function to the main, and there it's checked if it's correct. All right. Then we go to the topic of a control flow. We're going to touch on control flow a little bit because in Rust it's also a little bit different than in other languages. So I will clean up a little bit to get rid of some noise. And first we will address the if statement. So in this case, this is a very basic if statement. If 1 equals to 2, it prints something, and if it's not equals to 1 is not equal to 2, it prints something else. Well, of course, 1 is not equal to 2, so it will have to print the second part. And everything is fine. Nothing special about this. But the if statement can also return a value. So you can assign an if statement to a variable. So let's call it a equals. And then this if statement is the assignment of the let. And now we have to assign something. The print statements are not returning anything. So I will, if 1 is equals to, I will return false here, and I will return true here. And look at the situation that this line doesn't have a semicolon, and this line doesn't have a semicolon, and that means that just what I explained about the function, this is the return value of the if. Now, not of the function in this case, because we're in an if, and the if will return false in the then part and true in the else part. And to make this work, I have to print it or do something with it, at least, so I will print it with string interpolation. Like this, and then I have to put in another semicolon there, and now it's correct. So the value of a variable a is assigned the value true because 1 is not equal to, and then that value of a is printed into the print line. Of course, you can have several else constructions. So you can do, of course, something like this. Let's indent a little bit to make it more readable. If the number modulo here is 0, do this. Otherwise, if this is happening, do that. So you can have, of course, the if, else, else construct. And if I run this, this is working just fine. But this is the, well, this is a little bit of a normal stuff. Then that's about it for the if now. Now we're going to jump over to the loop. And I probably have to speed up a little bit. So Rust has a loop statement without any conditions or whatsoever, and that is called loop, and that will run forever. So if I run this, it will never stop. And that is quite convenient to have, because in embedded situations you almost always have to work with a loop. But also in what more normal circumstances, you can use a loop, and you can break out of it to break the loop. So if I have a little bit more complex, a more real situation, let's do it like this. I start off with a variable outside the loop. I will loop, and I will break at a certain point out of the loop, so nothing will happen. And it will assert. And then there's something special. The loop can also return a value to a variable, and only the loop can do that. So there's not the while can do that, the for can't do that as well, but the loop can do it, and you have to assign a value to the break statement. So in this case, I loop, I multiply itself by 2 every time, and when it's larger than 100, I will break out the value I at that point have, and assign that to the something variable. And after that, I will check if the something variable indeed is 128. So let's see if this is working, and this is working quite nice. So again, the loop loops forever unless you will break it. And if you break it, you have the possibility to return a value from the loop, which will be assigned to a variable of your choice, of course. In this case, it doesn't make much sense, because the I value is, of course, defined outside the loop, and you didn't especially need it at this point, but it is quite funny that you can do this. Then, of course, you have the possibility to use a for loop, which is a little bit more common. And this is the for each construction. I first define a array of five integers, and after that I loop over the array with the for loop. And one thing to mention is I have to take a iterable over the array. I will not jump into it now, because that's a topic in its own right. But if you have an array and you want to loop over it, you have to get the iterable of the array, and then you can say something like for element in a iter print each element. So if I run this, I will print 10, 20, 30, 40, 50, of course. Which are each element of the array in a nice for each construct. And then the final, and that's of course the for loop construction, where you have a predefined set of values you want to loop over, and then you can use the range construction. Here you say for item in 0.5, which means it will make a iterable from 0 to 4, 5 exclusive, and it will give you, just as with the for loop over the array, each element at a time. So it will give you 0, 1, 2, 3, 4, and it will print out 0, 2, 4, 6, 8. Oh yes, of course, 0, 1, 2, 3, 4, and it will print 0, 2, 4, 6, 8, yes. So this is it. For now, I want to ask you, finish the module and do the knowledge check. That would be nice to get everything up and running. And let's look at the questions then, if there are any. I have to find the Q&A that's here. I don't see any questions at the moment. Is that correct, Emma?
So a couple of questions have come through the publish section.
Sorry, I didn't hear you.
I'm happy to read some out if you like.
Oh yes, I don't have, oh, published here, sorry. I was in the why and where would I use Rust rather than Python? Yes, that's a very good question. Python, Rust is, of course, started off as a system language, so it was a replacement for C++ realm, and it's very fast. It's type safe, and so all these kind of things you need for a operating system or something like that. You can use Rust. Yeah, so for that target, for that purpose, you should definitely look into Rust, systems programming. But at the other hand, at the moment with WebAssemblies, and you can build all stack in Rust, and finding the right framework is of course always a difficult thing. But you can do anything with Rust. But especially systems programming. Okay, for collection, is it possible to specify the content types, key value type at declaration? Yes, that is possible. You can do it at declaration, but you don't have to. So typically, well, it depends on your circumstance. I do it either way. Sometimes it's quite convenient to do use the inference and do not the explicit typing. And sometimes it's very convenient to do the typing because it's also a sort of a documentation. You say to yourself and to the compiler, this is what it has to be, and that's nice. So yes, it is possible, and it depends on when to use it. Is it necessary to declare a variable as mutable to work with a hash map? Well, yeah. The hash map itself has to be mutable because you are going to mutate the hash map. You're going to put values into it. The values you put into the hash map don't have to be mutable, but there you go into the realm of borrowing, and that's a completely different topic. So it's a little bit more difficult than I showed you. But for the mutability part, the hash map itself has to be mutable, and the values going into not. Then a last question for now. In that case, what would be the use case for Rust in comparison to C++? Yes. Well, the thing is. Speed. C++, No, sorry, I was reading C# in my head, but you're saying C++. Yes, they're both on the same playing field. C++ and Rust are both playing the field of the systems software engineering. Yes, and the thing with Rust, it doesn't have a garbage collector, so that's a big bonus. So you don't have these random performance penalties. Yes, you're welcome. All right, these were the questions then. Thank you all. Please fill out the, how do you call it? Survey. That would be very nice and convenient and helpful for us. And see you next week, probably.
Thank you so much, Frick. It's been a pleasure to have you. I'm just posting in the link to the survey now and the event code that goes with that. I'll also just post the link to the Microsoft Reactor YouTube channel where this session will be posted within the next few days and available to watch on demand. And thank you everyone for attending and for all of your questions, and hope to see you back again next week.